In the previous lesson, what you learned was that every single point on a line is a solution to the equation of that line. Therefore, where two different lines intersect is the only solution to both of those lines, to both of those equations. However, from the technology you have available to you, that is the least effective method, although it is the easiest. It's also the least useful because in most ways you're not going to be able to take that information and then move on with it in various other aspects of math. However, this next method, called substitution, is probably the most useful going forward in math. Now, frankly, it's the most difficult of the three methods I'm going to show you, but like I said, it is the most useful. You can use this beyond this portion of Algebra 2. Here's what I mean. Here you have two equations. Both of them have y equals. They're both in slope-intercept form. Therefore, this is very easy to figure out where these two things connect. However, what if the answer is, I don't know, some weird fraction, like negative 52 over 117? That's hard to tell on a calculator. That's hard to tell just on a piece of graph paper. Also, what if one of these equations was not in slope-intercept form? Then you have more work you have to do. So, a different way to solve this would be plugging one equation into another equation. That is, you can't solve for both an x and a y at the same time. So, what you can do is plug one into the other, eliminating either an x or a y. Let me show you. Here you have y equals x plus 5 and 4x plus y equals 20. Now there's no way I can solve both of these things at the same time. However, since the first equation says y is x plus 5, y is equal to x plus 5, no matter what, y is going to be x plus 5, I can replace the y in the other equation with x plus 5. That leaves me with 4x plus x plus 5 equals 20. Notice there's no more y's here. That's the point. I now have only x's I have to deal with, and I can deal with that. So solve it like you normally do. Move the 5 to the other side by subtracting, because that's the opposite operation of plus. I got a couple of x's on the left here, so I got to put those together to make 5x. So now I'm left with 5x equals 15. Divide by the 5, because that's the opposite of times by 5. I get my answer of 3. X is 3. Now I don't have a y yet, so here's where I plug it back in to the first equation, to y equals x plus 5, to get my other answer. So now I'm saying x is 3. Just like before I said y is x plus 5, now I'm saying x is 3. So if I plug it back into that first equation, instead of y equals x plus 5, I'm going to have y equals 3 plus 5. Well, 3 plus 5 is 8. So I have my two answers, or I guess my one answer. X is 3, y is 8. Now, this does seem like it's more work than the last method. This seems like it's more work than just graphing them and see where they intersect. But like I said, it's more useful. There's going to be several times throughout Algebra 2 where you're going to want to substitute a variable for another equation. So knowing how to do it now is going to help you out later. But there's nothing really stopping you from graphing this. You could change 4x plus y equals 20 into slope-intercept form. You could graph that. Graph it beside y equals x plus 5. See where they come together. They're going to come together at 3, 8. But in order to do that, some work is required up front. Now, as I said, the graphing method, not exactly the best way to do all this stuff. It works fine for whole number answers. It works fine for stuff that's already in slope-intercept form. But the majority of the stuff you're going to get is not going to be in slope-intercept form. And a lot of the stuff that you're going to get is not going to have a whole number answer. Keep in mind, you're in Algebra 2 now. The answers are more complicated, they're more complex. Also, the graphing method really only works for two equations with two variables. we're going to get much deeper than that. So keep that in mind too. If you're going to be relying on that, when we get to the 3 equations with 3 variables or 4 equations with 4 variables, you're not going to be able to do anything on those. Let me show you one more. Here's an example in standard form. Now it's called standard form for a reason. It's the standard. Most equations that you're going to get are going to be in this form, where it's alphabetical and then equals and then a standalone constant number. As I said before, graphing's not exactly the best method because the majority of the problems you're going to receive look like this. They're not in y equals format. So here's how you can solve this problem using substitution. First, you got to solve one of these equations for a variable, meaning you got to get x by itself or y by itself. So I'm thinking the second equation, x minus 6y equals 4, would probably be the easiest one to do. So what you're going to do is get x by itself, get x equals. I would do that by adding 6y to the other side, because that's the opposite of minus 6y. I'd end up with x equals 4 plus 6y. Since we have x is 4 plus 6y, I can replace any x that I see with 4 plus 6y. So in the problem above, I can replace that x with 4 plus 6y. Once I do that, I'm going to end up with 2 parentheses 4 plus 6y, because I did have an x there, plus 10y equals 8. Notice there's no more x's. Again, that's the point. After that's done, solve it like normal. Here I'd have to distribute the 2. Once that was done, I would probably subtract the 8, because that's the opposite of add 8. Once that was done, I got a couple of y's on the left here. Got to put those together and make 22. And once that's done, I got to divide everything by 22, because that's the opposite of times. I end up with y equals 0. Now I only have one of the variables solved. I only have y equals 0. I do not have x equals anything yet. So what I got to do now is plug this 0 back into the other equation, back into x minus 6y equals 4. Since I'm saying y equals 0, anywhere I see a y, I can replace that with 0. So in this case, instead of x minus 6y equals 4, I'm going to say x minus 60 equals 4. Well, 6 times 0 is 0. What minus 0 equals 4? 4 minus 0 equals 4. So now I have y equals 0 and x equals 4. And these two numbers, the x and the y, satisfy both of these equations. It is the only pair of numbers that will make both 2x plus 10y equals 8 true and x minus 6y equals 4 true. The big thing I want you to get out of substitution, this particular method of solving systems of equations, is that you can substitute a letter with an expression. That is, a variable doesn't have to equal a constant number. A variable can equal anything. And that's why this particular method can serve you much better in the future compared with graphing.